Okay, moving on to the next speaker, next to me. Beatriz Vaquero is talking about the Yebes Laser, Yebes Laser Ranging Station development status 2022.
Okay, good morning again. Besides being a member of the local organizing committee, I'm also the project manager of the YLARA station at Yebes Observatory. And with this presentation, I would like to show you the evolution of the project and the current status. Okay, let me start with a little bit of history. The idea of having an YLARA station at the Yebes Observatory started like 14, 15 years ago. That was the first time that some people from Yebes attended to an ILRS workshop. The observatory wanted to extend its capabilities in space geodesy. So they developed the YLARA Project. This project included 4 biggest radio telescopes distributed at Yebes, Canary Island, and 2 of them at the Azores Island. And with this network, we are going to have 4 radio telescopes distributed in 3 different tectonic plates. And also, this project wanted to establish an YLARA station at Yebes Observatory to have a fundamental station there. But in that moment, I'm talking about 10 years ago, if you remember, we were in the middle of the economic crisis. So it was difficult to find funds for the YLARA station and other projects. So we have to delay a little bit the construction of the YLARA station, sorry. But in 2013, thanks to the 40-meter radio telescope at the observatory, the observatory became part of the list of ICTS in Spain, and ICTS is a singular scientific and technological infrastructure, and currently the observatory is the only infrastructure with this characteristic of this qualification at Castilla-La Mancha. So thanks to this qualification, we can apply for funds coming from the for the ERDF funds. And these funds were for several projects inside the observatory. The YDALGO Operation, development infrastructure and laboratory activities for space geodesy at the Yebes Observatory, had 2 objectives. The first one was to build a new building at the observatory for workshop and laboratories, because as you will see this afternoon at the observatory, we are also a technology development center, and we design, develop and construct most of the technology that we use for the radio telescope, and also provide this technology to other observatories around the world. And the second objective, was to build the YLARA station at the observatory, turning the observatory into a core site, unique in Spain, and fulfilling the requirement of the YDALGO project at the biggest radio telescope of the YLARA project. The initial works to apply for the ERDF fund started 6 years ago, and they were approved in January 2018. During 2019 and 2019, we started to define the main specification of the stations and the general design. And we also acquired some components and devices, and we choose the location of the station inside the observatory. But at the end of 2019, we decided to launch a contract for a turnkey solution, because from the administrative point of view, it was easier to handle. And so we started with this turnkey system, but we insisted a lot that the Yebes team wanted to be involved in every step of the project. The installation at the Yebes Observatory started 2 weeks ago with the installation of the dome, and the next subsystem will be installed next spring, and we hope to have the station operative or almost operative by summer. Okay, about the general requirements we established before the starting of the contract, perhaps the most important decision was to, okay, we wanted to have a state-of-art SLR station, follow with the last advances and techniques. That meant to have the laser packets installed in a piggyback configuration. But also we wanted to have the tranquility and the expertise of the classical designs that they have the laser package installed in a room, conditioner room, over an optical bench, and then set the pulses through a code focus. So finally we decided to have both configuration at the station. And another important things we decided, we wanted a telescope with a diameter bigger than 70 centimeters, a laser with a 2-color capacity, a kilohertz system, of course, and okay, and another important specifications. About the location of the stations, it's going to be inside the observatory, near to the other facilities that we have, and it's going to be integrated in the local time network. We are going to build 3 pillars more around the stations, and to include the station into the network. The weather at Yebes is the typical weather we have in the center of Spain. It's quite dry with pretty hot in summer and hot and cold in winter. And as you have seen during this day, with the gradients, the temperature gradients here are quite high. So as we say here, we can have 4 seasons in one day. But in general, I think the location for an SLR station is quite good because we have a lot of extremely clear days with no cloud and excellent visibility. Okay, starting with the current status of the station, we have built the construction of the building started last May and is nearly to finish, as you will see this afternoon. So it took 6 months as the organization of the workshop. And so here you can see a little bit the evolution of the building. We think it's pretty well, pretty good design because we have a lot of space with several rooms, the code room, the control room, also a small laboratory and warehouse space. And of course the dome and the space inside the dome. For the telescope assembly, that include the mount, the code path, the receiving and transmitting telescope, we selected a company from Italy called Officina Stellare. Didn't have experience building system for SLR application, but they proved to develop very robust design with high quality, and they were the reason to select this company. You can see here some of the specifications of the system, and the setting up of the telescope is nearly to finish, and the factory acceptance test is going to take place in 1 month, more or less. About the dome, we purchased the classical slit time Bader dome. Our dome has a diameter of 5.3 meters. And it was installed at the observatory 2 weeks ago. And so you will see it there. For the time and frequency system, the hydrogen miser was available at the observatory because it is used for the radio telescope observation. So we just have to acquire a timing distribution platform. In this case, the land time M3000 from Mainberg, plus the timing antenna. Although at the observatory we currently have a complete meteorological station, we decided to acquire a new one, complete new one for the SLR station, just dedicated to the system. That is going to be placed next to the SLR building, and the sensors are going to be at the same height of the invariant point of the telescope. Also, the YLARA station includes a station protection unit developed by DIGOS. This station is responsible to protect the station from potential damage caused by unsuitable or severe weather situation, for example, a storm. This unit takes information from different sensors and to detect the possible risks. Okay, about the heart of the station, the laser. We choose a laser from a Canadian company, Passat. It's the same system of the YLARA station you showed before. The main characteristics, 1 kilohertz pulse repetition rate. You can see here the energy per pulse, pulse with 7 picoseconds at green, 8.5 at infrared. And the integration of the system was designed and integrated by IWF at Graz SLR station. For the detector package, we follow a similar approach. The detector package is going to be installed in one of the Nasmyth focus of the telescope. It includes a CSPAC detector for the green color and an infrared detector for the infrared signal. Everything has also been, the package has been designed and integrating Graz also, following the same design like they follow for the JAXA or ESA stations. These packages, the laser and the detector packages, are already finished and they were tested last May. So they are ready to be installed on the telescope assembly once the telescope is finished. Another important subsystem that has to be included into an SLR station, the ranging generator, and the widely used RGG Event Timer. Okay, I talked before about the station protection unit, but for an SLR station, it's also critical the laser safety subsystem. For the LARA station, we are going to use an ADS-B receiver and also a FLARM 81 receiver, and an OMEA all-sky camera, although from the safety point of view, the camera is a secondary system. When we acquired this subsystem, we installed it indoor to check a little bit the operation, but during this year, they were installed on the roof of our main offices building to check their performance, and they were installed at the same way, more or less, that they are going to be installed in a future station. And my colleague Jose Rodriguez also has a poster with information about the observation carried out with the all-sky camera. And also we did this because we wanted to know a little bit about the air traffic around the observatory. Okay, finally, but not less important, the brain of the station, the software, is the well-known software developed by DICOS around 10 years ago and currently working in several stations. Okay, if you have any questions about the software, I think you can ask DICOS better than me. And okay, up to this point, I have presented all the subsystems that are included into the YLARA station as they were planned a couple of years ago or 3 years ago. But we also have in mind to have a flexible design, thinking about future application or observations. So I'm going to talk about a very new device that is going to be implemented also in the station. So recently, and when I said recently, it was last week, a contract to acquire a laser system for space debris observation was awarded. The system is an Inolas split light Evo 2, and these are the main characteristics of the laser. This laser is going to be installed in the cooler room instead of the piggyback configuration. And our interest in the space debris observation is, first of all, because I think it's something that is a problem that affects all of us. And second, because a few months ago, the IGN was involved in several tasks related with SST, representing our ministry. And okay, that's all the things we are going to have in our station in a few months. And we will see in the future, because we are open to have more new things, new experiments, new observation, but first of all, we have to fulfill with our first goal, that is to observe cooperative satellite and being part of the ILRS network. So thank you very much for your attention.
Thank you, Bea. Any quick questions from the audience? Yeah, that's right. Okay, thank